All right, so this is going to be a quick little lesson on absolute value inequalities. So, a couple of things just to recap. Absolute value, so we're solving linears, so we're just going to make this a very basic one, and the very basic one I mean by this is we're going to do an absolute value linear inequality when greater than or less than a constant. So this is not like a higher level. This would be an introductory to these particular videos. So if you're looking for something higher level, this is not the video for you unless you need to learn the bare basics. And the bare basics are this. So absolute value has two cases, and we're going to evaluate those cases via absolute value inequality. So first off, we'll go back to the graph of an absolute value. So we should know the graph of an absolute value is a v if and only if the function is linear. Okay, so it will only be a v if that thing is actually linear. Okay, it becomes something else if you make it a different function. So why is it linear? Well, it's pretty simple. So absolute value is this idea that the outcome, so the output, will need to be its positive value. So if I give you an expression like this, the absolute value of, say, 1/2 x plus 2, I'm sure that you've all have graphed at this point via Algebra 1, all right, the equation of a line. So here is m, here is b. Yes, so we graph it very quickly. So we go up 2, we go plot that y-intercept, we go up 1 or down 1 to the left 2, down 1 to the left 2, right? And we draw this line. And we get this, right? And that's what a linear equation looks like. And absolute value is completely happy with all the y values that are positive, okay? But what it's not happy with is it's not happy with all the y values that are negative. So this is looking at it, and it's looking at it, and it's going, boo-hoo, I don't like you that you're negative. So I want you to be positive, right? Well, in mathematics, how do you make one negative become a positive? And in mathematics, the quickest way of doing that, and it works for all numbers, okay, and is we usually just simply multiply by another negative. Now, absolute value doesn't want you to change the number, it just wants you to change you from being negative to being positive. So what happens is all of these negatives get multiplied by a -1, and what happens in this part is that they then reflect across that x-axis, and you're now left with the graph of a v. So now this is why, okay, the absolute value looks like this. So a couple of basic ideas. Absolute value is always 0 or greater. So that means the outcome must either be 0 or greater. So that means all other absolute values besides 0 have to be greater than any negative number. Okay? So the absolute value of, say, a, all right, is always greater than or equal to 0, okay? So when dealing with inequalities, one of the first things that you should be looking out for is what happens if it says, when is the absolute value greater than, a negative number, okay? So when is the absolute value greater than a negative? Well, that's pretty simple. Absolute values are always larger than 0 or equal to it. And if you look at a quick little graph, it's asking you, when are positives greater than negatives? And the answer to that is always. Any number that I plug in here for a is going to have a positive output. So therefore, this value, just as is always going to be greater than that. So this one will be any number in the world, all real numbers, right? The next thing you could look out for when doing these, okay, some expressions, especially around these negatives. Well, what if it says, when is the absolute value less than a negative number, right? And it has to be strictly less than, right? So what happens is, looking at this graph again, well, when is a positive number below a negative number? And I mean, like, below would be, here's a negative number, when is a positive number going to be down here? And the answer to that is, well, all positives are up here, so that would be never. So any number I plug in here will never give me a number smaller than another negative. This is your no solution case, okay? And the other one was your all real numbers, right? So, but let's talk about if you don't have that special circumstance, right? Those two things you should be looking out for. What if I have something else? And that something else would be, say, hey, what happens, I want to know, when is 1/2 x plus 2 greater than or equal to, say, 4, okay? So if you notice that these two things are rays, okay? So case 1 was that function as is. So here it is going along, and this ray goes on forever. So at some point, this ray is going to pass the number 4 in height. Well, this side, right, because we reflected it up, is now also traveling up. So this is what we call case 1, right, which is the positive case. And over here is case 2, which we call the negative case, all right? So the positive case in this, all right, is just dealing with what is given to us in the inequality as is, all right? So for us, what I'm going to do is I'm just going to simply use positive 1 multiplied by this. Well, 1 times anything is, well, I get 1/2 x plus 2 is greater than or equal to 4, because that will happen. Case 1, all right, that will happen for. Well, this one, right? Well, case 2, again, was created using part of case 1. Yes? It was just using cases 1s down here. Well, how do we get these up here? Well, we took the first case, all right, and we said, hey, let's just multiply this by -1, and we got 1/2 x plus 2, all right, and that's what we got. So this expression right here is this line actually just multiplied by -1, all right, and that's when it looks like this. So I want to know now, when is this line also greater than or equal to 4? And you have case 1, case 2, and from here we just now simply solve. So I go through and I go -2, -2, because when we solve inequalities, again, we use properties of equality because we're trying to actually find a maximum or minimum value that we need to use, okay? So I then go through solving. I get 1/2 x is greater than or equal to 2. At this point, all right, we need to divide, but I don't like dividing by fractions. So you should get in the habit as well, okay, of possibly when you have fractions, when you start moving up in higher mathematics, is knowing that division by a fraction is the same thing as multiplication by a reciprocal. So 2/1, which is just number 2. So I'm just going to go on the other side and multiply by the value of 2. All right, now I didn't do anything with a property of equality that was negative, because remember, if it's negative, the inequality needs to flip. So in this case, because my property of equality is a multiplication by a positive, I can leave the inequality as greater than or equal to 4. Okay, so then we move on from here. And moving on from here, we go to the other side, and there's multiple ways to do this problem. I'm going to show this example via distributive property. So distribute the -1, and I get -1/2 x minus 2. Now, a lot of people sometimes think they should flip this inequality because you multiplied by a negative, didn't I? And the answer is no. You don't flip it unless you're using a property of equality. That's important, okay? So this is going to be greater than or equal to, and a property of equality is when you do it to both sides. So I'm only multiplying the left by -1, not the right, so this doesn't flip. It is 4. And now I go through and solve it, right? So I get -1/2 x minus 2 greater than or equal to 4. Add 2 to both sides. I get -1/2 x is greater than or equal to 6. And then at this point, now I'm going to, again, you can divide by -1/2 if you struggle with this, but I do recommend, okay, that you multiply. So -2/1, which is just the good old -2. Now, because my thing in blue, which is my property of equality, is a multiplication, okay, or a division in this case, okay, multiplication, I will flip that inequality. So that inequality, okay, the x stays put, it still goes straight down. All right, so we take the x. Now this inequality goes from a greater than to a less than, and 6 times -2 is -12. So what I've got going on here is this. Now this inequality pops up, or this compound inequality. One of the things you definitely need to know about absolute values, all right, with these particular ones, is going to deal with what does a greater than mean and what does a less than mean. So a greater than will always be an or, okay? And it's because absolute value represents a distance away from 0, or a function's 0, sorry. So it's a distance away from a central point. So if I am greater than, it means, it needs to me, okay, it means, all right, that you must be at that point or farther away. So if you look at a number line, and I call this my central point, greater than means you need to go to that distance and then be farther away, okay? So, but you don't just go to the right, you can also go to the left, and then you need to be farther away, Okay? So what you get for a greater than is this thing that goes opposite directions. And you should know that I have an answer here will work, or an answer here will work, which means that negatives, in this case, it doesn't matter, right, if I call this central number, but it doesn't matter. It means the numbers to the left or the numbers to the right will work. They don't both simultaneously have to work, okay? So in this case, this is the or inequality. If I flip this to a less than, well, less than would be this same exact graph talking about the central point, which means go to your central point, but I don't want you any farther away than that value, but you can be closer. So this goes back to here, okay? So this one is a closed interval, which means that you need to be between here and here, okay? So that's where a less than will be an and. Now, why is that important? Because I now need to know for this one that when I graph an absolute value or, that it is okay that I simply have a solution and I graph it on there. So this case is -12. So x is less than or equal to, fill it in, and I'm going to the left. This one is greater than 4, so bubble it in and go to the right, and I'm at 4. So this is the or. X values can be less than -12, or they can be greater than +4. And what that simply means that if I choose a number greater than 4, all right, and plug it in here, that answer will also be greater than or equal to 4 when I evaluate it. So a couple things about absolute value inequalities. Based off of this again, absolute value inequalities are always positive. So there's a couple cases with inequalities you need to be worried about, and that deals with the am I greater than or less than a negative? When are you greater than a negative? Well, all positives are always greater than a negative. So that is the all real solution, all right? You don't even do the work to those problems, all right? You just say, oh, absolute value greater than, if I made this problem, okay, -4, I would have done absolutely none of this work. When is a positive greater than a negative? Always, all real numbers, okay? If I had this same problem and I flip this, okay, just to run back through, less than or equal to. When is a positive less than a negative? Never. That would be no solution. None of this work exists. So if I have an absolute value inequality compared to a positive number, then there is work that is involved. Otherwise, it's just analytical, okay? So be careful about absolute values and negatives over here versus absolute value, okay, and positives. Absolute value, positive, showing work, okay? And that's it. So there's the quick little rundown of absolute value inequalities. I hope that was helpful. Let me know. Hit the like button, dislike button, either one, doesn't matter. Just let me know what you think, all right? Have a good one.